Today, we're talking about the intelligent edge. It's a world where the line between incredible success and, well, catastrophic failure can be measured in less than the blink of an eye. So let's dive right in.
In this age of autonomous everything, from cars to factories to surgery, it's all about being faster, smarter, more efficient. But what's the one thing, the one resource that governs all of it, that we absolutely, positively cannot get back?
It's time, yeah, but not the kind of time you and I are used to. In these crazy high-stakes environments, we're talking about milliseconds. That's thousandths of a second. This is the new gold standard for performance, and there is zero room for delay. And that brings us to this really crucial idea, the latency budget. Honestly, you should think of it like a millisecond wall. It's this unforgiving, absolute limit on how long something can take to react. And if you break it, the whole system can just fall apart.
So, get this. For something like a super precise robotic arm on a factory line, that budget is less than 1 millisecond. 1! If it takes any longer, that arm could make a mistake that costs millions or causes some serious damage.
Or how about quality control? Imagine an AI camera watching products fly by on an assembly line. The entire job, from spotting a tiny defect to flagging it for removal, has to happen in just 6 to 12 milliseconds. It's an insane race against the clock.
And even for something that feels a bit more human scale, like augmented reality for a mechanic, the limit is still only about 100 to 150 milliseconds. Any slower, and that digital overlay you're seeing starts to lag behind reality, making the whole thing feel broken and useless.
Okay, so this begs the question, right? We've got all this nearly infinite computing power sitting in the cloud. Why on earth can't it handle these tiny deadlines? Well, the problem isn't about power, it's about physics. Yep, it all comes down to the speed of light. The cloud is just too far away. Seriously, sending data to a server halfway across the country and waiting for a response can easily add over 100 milliseconds of delay. That alone just blows past most of those budgets we just talked about. And this is exactly why the edge, doing the computing right there on site, is such a game changer. You cut out that long round trip, and bam, you slash latency by up to 90%. Now real-time is actually possible.
So, the solution starts with a simple but radical idea. Stop shipping all your raw data off to the cloud. Instead, you've got to bring the brains of the operation right to where the action is.
And we do that with what are called AI-orchestrated edge clusters. Just picture these little groups of powerful computers sitting right there on the factory floor, or even inside the machine itself. They're constantly listening to sensors, feeling for vibrations, checking temperatures, all in real time. And if they detect an anomaly, something that hints a failure is coming, they can trigger a maintenance alert all on their own.
Now here's where it gets really cool. By processing all that data locally, these systems don't just kill latency, they actually improve the accuracy of predicting machine failures by a massive 35 to 40%. This is what lets companies shift from reacting to problems to actually getting ahead of them. It's truly proactive.
Okay, so now you've got this amazing setup, but you have thousands of these smart devices out in the field. This creates a whole new headache. How in the world do you manage, update, and coordinate this massive, distributed fleet of tiny brains?
Well, the answer is a kind of specialized operating system designed just for the edge. A great example of this is KubeEdge. Think of it like a conductor for a huge, sprawling orchestra of smart devices, making sure every single one is playing its part in perfect harmony. And for those in the know, yes, it's built on top of Kubernetes, which is the gold standard for this stuff.
And here's the kicker, it's incredibly efficient. A lot of these edge devices don't have a ton of power or memory to spare. So KubeEdge was designed to be super lightweight. It has a memory footprint as small as 70 megabytes. That is tiny. It allows this powerful system to run on even the smallest pieces of hardware. So let's just quickly run through its best features. It's built on Kubernetes, so developers already know how to use it. It coordinates things seamlessly between the cloud and the edge. But honestly, the absolute killer feature is this one right here, edge autonomy. This means if a device out on the edge loses its internet connection, it doesn't panic. It just keeps on working, making decisions and doing its job all by itself. That's a huge deal.
All right, so we've got the local intelligence, and we've got a great system to manage it. But there is one final critical piece to this puzzle. What happens if the local network itself turns into a giant traffic jam?
So here's the problem. Your standard 5G network is what we call SLO unaware.
Now, SLO just stands for Service Level Objective. It's the official name for that latency budget we've been talking about. And being unaware means the network treats a supercritical, time-sensitive signal from a robot with the exact same priority as, say, a non-urgent data backup. It just doesn't know the difference.
And this is where a brilliant framework called SMEC comes into play. SMEC is SLO aware. It basically acts like an intelligent air traffic controller for your 5G data. It can see which data packets are getting close to their deadline, and it gives them a VIP lane, making sure they get to the front of the line and arrive on time. And what's really clever is it does all this without ever needing to look at your encrypted data, which is great for privacy.
And just look at the difference this makes. It is night and day. On a traditional network, under heavy load, deadlines were met less than 6% of the time. Less than 6. With SMAC directing traffic, that number shot up to 96%. That's the difference between a system you can't rely on and one you can literally bet your entire business on.
So what happens when you put all of these pieces together? You've got the local processing, the smart management system, and the deadline-aware network. Well, you don't just get a faster system, you actually create something totally new, a whole new category of artificial intelligence.
We've entered the era of precision edge AI. You see, traditional cloud AI is often just good enough. Its performance can kind of drift around depending on how busy the network is. But precision edge AI is different. Its behavior is deterministic. That just means it's predictable, it's trustworthy, and it is rock-solid reliable. Its performance isn't a maybe, it is a guarantee. And that right there is why all of this matters so much. When you're talking about safety-critical systems, things like robotic surgery or a car's collision avoidance system, good enough is a recipe for disaster. What you need is certainty. Precision AI turns the dangerous uncertainty of network delays into the safety of guaranteed performance. So I want to leave you with this thought. Once performance is guaranteed, down to the millisecond, what new possibilities does that open up? What jobs, what tasks that we always thought were too complex were just too dangerous for a machine? What can we now confidently trust them to do? That's the future that the intelligent edge is building for us right now.